Okay, here's another video of a sample problem for you. This one is actually number 50 from the homework. It's a 3-dot problem. I don't really think it's that hard, but I'll read it to you and then I can draw a picture. It says, 2 seconds after being projected from ground level, a projectile is displaced 40 meters horizontally and 53 meters vertically above its launch point. So we'll just have a projectile here, gets launched, and then sometime later over here, 2 seconds, so t equals 2. Its x position is 40 meters and its y position is 53 meters. And the question is, what is v0x? And then what is v0y? That's parts A and B. And then we'll tackle part C in a minute. So we have some conditions over here, v0x and v0y is what we're looking for. And just as usual with these problems, sometimes it helps to just start out with reminding ourselves what happens in the horizontal direction. And we just have, at the x position, it's just going to be v0x times t. And that's what one of the things we're looking for. And then the vertical direction, so make sure you all can still see that. In the vertical direction, we've got the y position is 1/2 negative g, t squared plus v0y times t plus y0. Let's go ahead and choose the ground level to be y equals 0, and I already chose with sticking the negative there to have the up position be positive and have the down position, so up direction to be positive and down direction be negative. So the horizontal one's actually really easy because we have a time and we have a horizontal position, and even the vertical one we have a time and we have a vertical position. So if I just plug things in over here, 40 equals v0x times 2, then v0x should be 20 meters per second. So that's pretty easy to figure out. I'll just write that down over here, 20 meters per second. And then in the vertical direction, let's see if I have enough space over here to fit everything in. So I get 53 is 1/2 negative 9.8, 2 squared, I gotta move down a little bit, plus v0y times 2 plus 0. And you have to work out all this math, which isn't really too hard to do. And according to the book, this is going to give you v0y is 36 meters per second. So that is 36 meters per second. So that's pretty easy. Once again, I don't know why this is a 3-dot problem, but we'll continue on. Part C says, at the instant the projectile achieves its maximum height above ground level, how far is it displaced horizontally from the launch point? So projectile is going to start, it's going to go like that, and we want to figure out at this instant right there, what is this x distance right there? So that's not so hard to do. I think we can use the fact that we know that in the y direction, its velocity is going to be 0 in the y direction at this midway point, and figure out the time, and then use that time to figure out the x position. That should be pretty easy to do. So let's talk about the vertical direction. In the vertical direction, we can use velocities. V equals v0y times, I'm going to do a t plus v0y. And we know that at this point over here where it's at the maximum height, that its vertical velocity is 0. Oh, I should write vy right there. Sorry about that. So I'm going to get 0 is negative 9.8, and t is what we don't know here, plus my initial vertical velocity of 36. Good. And then according to the book, if you do this out, yeah, which makes sense that the time here is going to be 3.7 seconds. And now let's move over into the horizontal direction. And we just have the x position is just v0 x times t. And that's what we're looking for. We know the v0x is 20. 20, oh, look, I put units in there, times 3.7 seconds, and multiplying those things out, we should get 74 meters. So there you go. Once again, a 3-dot problem seems pretty easy to do, and just keep things horizontal, keep things vertical, keep things horizontal, separate them all out, and it should be relatively easy to do.